Okay, so in the physics classes until now, we have seen what derivatives were. So what derivatives were? If you have any function y equals to f of x, then the derivative is written as dy by dx. Okay. Uh, so what was dy by dx? This was what? Derivative. So what was dy by dx? If you have any function, say y equals f of x, you have some function, say this function. So what was the derivative of this function? What was the derivative of this function? Derivative of this function was the slope of this function. So if you take any point and if you take a small increment in x in the neighborhood of that point, this was x, this was x plus dx. So this became your dx, and correspondingly this was f of x and this was f of x plus dx. So the difference between f of x plus dx and f of x was dy. So this was dy. So here this was your dx and this was your dy. So how do you measure slope? How do you measure slope? Slope is given by dy by dx. So if you have any line like this, its slope is what? Delta y by delta x, correct? If that increment is small, then this delta y becomes dy and this delta x becomes dx, and your slope turns out to be dy by dx. So basically derivative was slope. Now using this, what did we get? Using this, what did we get? We got this expression. We got this expression. So what was dy here? What was dy? Dy was this line, right? This length. This length was dy. This was dy. So dy was f of x plus dx minus f of x, because it's the difference between those two values, divided by what was dx? This was dx. So this was the fundamental equation of the derivatives. This was the fundamental equation of the derivatives. Now using this expression, you derived derivatives for various functions. You derived with derivatives for various functions, like for example we had taken what? Y. So okay, so what did we take? We took y for various functions. Okay, we took y for various functions, like mx plus c, and we have seen what the derivative of a constant function is, what the derivative of y equals to x is, what the derivative of x square was, x cube was, x power n was. We have also derived derivatives for sin x and cos x, correct? So I'm writing the derivatives here. So let me write the derivatives here. So here I'll write the derivatives dy by dx. So what was the derivative of mx plus c? It was m, because the slope of line mx plus c is m, and it is a constant because it is a straight line. And what was the derivative of any constant function? Constant function is a horizontal line, so slope is 0 everywhere. So for any constant, the slope is 0. What was the derivative of function y equals to x, or f of x equals to x? This is also f of x, right? So f of x equals to x. The derivative was 1, because slope of line y equal to x. What is line y equal? What is the function y equals to x? It is a straight line passing through origin and making 45 degrees. Okay, with positive x-axis in anti-clockwise direction. So even by the definition of tan theta, okay, slope is also equal to tan theta. Theta is the angle that the line makes with the positive x-axis in anti-clockwise direction. It was tan 45 1, and we derived 2. And what was the derivative of x squared? It was 2x. What was the derivative of x cubed? It was 3x squared. And x power n was n times x power n minus 1. We derived this 2. And what was the derivative of sin x? Sin x was what was the derivative of sin x? Derivative of sin x was cos x. And what was the derivative of cos x? It was minus sin x, correct? So we derived all these, each and every function we derived. And after that, what did we do? We also derived two rules. One was called chain rule, and the second was product rule. What did chain rule say? Now, if you have a function of a function, what do you mean by function of a function? For example, if you have some function like sine of x squared, then dy by dx was, so we do not know what derivative of sine of x squared is, but we know what the derivative of sine x is, we know what the derivative of x squared is. So what I do is I keep x square as it is and assume it to be like x and write the derivative of sine x. What was the derivative of sine x? It was cos x, but here we have sine x squared, so we write cos x squared. But in place of x, we don't have x here, we have x squared, right? So I have to take the derivative of that again and multiply. That was chain rule, into 2x. So the derivative of sine of x squared was cos of x squared times 2x, correct? Similarly, I'll write second example. If y equals to cos of x power 10, then the derivative will be, I write the derivative of cos of x power 10, which is actually minus sine of x power 10. If I assume that there is x here, but in place of x you have x power 10, so you take the derivative of that function and multiply. So it's 10x power 9, 10x power 9, right? So I get the derivative of this function. So what is the derivative of y equals to cos x power 10? It is minus of sine x power 10 times 10x power 9. This was your chain rule. And what was the product rule? Second, let's go to product rule. So we have seen the product rule also. In product rule, what did you see? In product rule, you have seen that if you have a function which is a product of two functions, like y equals to u into v, y, or if you write in detail, it is y of x equals to u of x times v of x. So y of x is a function of x, but it is actually product of two more functions, u of x and v of x. Then dy by dt was given by, what was dy by dt? Dy by dt was given by u of x, you keep as it is and multiply with the derivative of v of x. So okay, plus you keep v of x as it is and multiply it with the derivative of what? U of x. So if I want to write this in a simpler way, what will it be? If I want to write this in a simpler way, what will it be? It will be, if y is equal to u into v, then dy by dx is equal to u dv by dx plus v du by dx. Okay, and for that also we have seen example. I'll just repeat that example and then proceed with the new concepts. Okay, so for example, if you have a function like x cube times sin x, so y equals to x cube times sin x. So this function is product of two simpler functions. One is x cubed and the other function is sin x. So if you want to take out the derivative of this, dy by dx is equal to, you keep x cubed as it is and multiply it with the derivative of sin x, which is cos x, plus you keep sin x as it is and with the derivative of other function, which is derivative of derivative of x cubed, which is 3x squared. So this is your answer. So this is your product rule. Clear? Okay, fine. Now based on this product rule, I will derive a derivative of a few more functions. Derivative of a few more functions. Okay. Okay, fine. Now what about this function? If y equals to tan x, how to take the derivative of this function? So let us see how to take the derivative of this function. So I'll write y equals to tan x as y equals to sine of x by cos of x, which can be written as sine of x times 1 by cos of x. So basically I am writing this tan of x in terms of the functions, products of functions whose derivatives we already know. Now before going into that, I want to ask you one question. What is the derivative of 1 by x? What is the derivative of 1 by x? So what is the derivative of 1 by x? Suppose let me write one function, okay, y equals to 1 by x. What is the derivative of this? Okay, y equals to 1 by x. What is dy by dx? So this yellow part and white part are different, so don't mix them up. So this yellow part is a separate problem, this white part is a separate problem. So I am just reminding you one more formula. So 1 by x can be written as x power minus 1. You know that derivative of x power n is what? Derivative of x power n is n times x. So okay, let me just correct it. I shouldn't write dy by dx here. I should just write y first. Okay, y equals to x power minus 1. Okay, you know what derivative of x power n is? Derivative of x power n is n times x power n minus 1, correct? So this is the derivative of x power n. So here, what is in place of x? What do you have in place of x? You have minus 1, right? So you use that. So dy by dx equals to, according to our formula, it is n comes to the front and multiplies x power minus 1 of minus 1. N minus 1 is minus 1 minus 1. So it's what? It's equal to minus of x power minus 2, which can be written as minus 1 by x squared. Okay. So we got one more formula that we have to remember. Okay. Actually, you can use this formula to get the derivative, but it is better to remember derivative of 1 by x just on your to keep this expression on, you have to keep this expression on your fingertips because it appears a lot in the problem. So the derivative of 1 by x is what? Minus 1 by x squared. Okay, you remember this. Derivative of 1 by x is what? Minus 1 by x squared. Okay, and this we got it using this formula which we already derived. Clear? Now let us go back to our problem. So our problem was y equals to tan x. What was the derivative? Okay, so if y equals to tan x, what was dy by dx? That was our question. Okay, let us do it again. Now that we know that the derivative of 1 by x is minus 1 by x squared, we can use this formula. Okay, so let me go back to that question. What was our question? If y was equal to tan x, what is the derivative? So I'm writing y as a product of functions. I'm writing y as product of functions. I'm writing y as product of functions that we already know. So it is equal to sin x by cos x. So I can write it as sin x times 1 by cos x. So it's like y equals to u into v, right? It's like y equals to u times v, where u is what? Sin x, and v is what? 1 by cos x. Clear? V is what? 1 by cos x. Now let us try to solve this. So what is dy by dx? Use product rule. You keep sin x as it is, and you take out the derivative of 1 by cos x. Now 1 by cos x is not a function that whose derivative we already know. It's like 1 by x, right? So derivative of 1 by x is minus 1 by x squared, but in place of x, what do you have? Cos x. So I will write 1 by cos square x. Okay, if it was x there, I would have written 1 by x squared, minus 1 by x squared, but in place of x you have cos x, so I'm writing minus 1 by cos square x. Now I have to use chain rule because in place of x we have something else, so I have to multiply the derivative of function which was present in place of x. What was present in place of x? It was cos x. So what is the derivative of cos x? Minus sin x. So I am using chain rule also here. I am using chain rule also. Okay. So what was dy by dx here? It was u into dv by dx, plus v into du by dx, correct? So here I have already written u, which was sin x, okay, and what was dv by dx? It was derivative of 1 by cos x. It was derivative of 1 by cos x. So what was the derivative of 1 by cos x? What was the derivative of 1 by cos x? So I am considering it as 1 by x. So derivative of 1 by x is minus 1 by x squared. So instead of x you have cos x here. So instead of 1 by minus 1 by x square, I am writing minus 1 by cos square x. And by chain rule I am multiplying with the derivative of cos x, which is minus sin x. Clear? Plus v du by dx. V du by dx, that means 1 by cos x I will keep as it is, times derivative of sin x. What is derivative of sin x? It's cos x, correct? It's cos x. Clear? So this is the product rule. So we have used both product rule as well as chain rule in this derivation. Okay, now next step. In the next step I'll use different color. So what is dy by dx? If you simplify this part is 1 because cos x by cos x is 1, correct? And what about this part? This part is what? If you see, this minus minus becomes plus, and there is sin x into sin x in the numerator, which is sin square x, and cos square x in the denominator. So sin square x by cos square x is tan square x, correct? But we already know the identity. What is 1 by 1 plus tan square x? What is 1 plus tan square x? It is secant square x, secant square x, correct? So what is the conclusion? Our question was this: if y was equal to tan x, what is dy by dx? So dy by dx is what? Secant square x, correct? Now you can use these kinds of methods. That means you can use both product rule as well as chain rule to derive derivatives of functions, which which can be written in terms of the functions whose derivatives we already know. So I don't want to derive all. If you want, you can derive by yourself, but the method is same. Okay, the method is same. So I'll just write down the derivatives of some new functions. Okay, so some new functions I'm writing. Here I'm writing function, and here I'm writing the derivative. Okay, dy by dx. So derivative of tan x is secant square x. This you have to remember. Derivative of secant x, this also you can derive, but I'm not deriving because we don't have time. Secant x into tan x. Derivative of cot x is minus cosecant square x, and derivative of cosecant x is minus cosecant x cot x, correct? So these are somewhat similar. See, for example, tan x is secant square x, cot x is minus cosecant square x, right? And secant x is secant x tan x, and the derivative of cosecant x is minus cosecant x cot x. So there is some pattern here which may help you to remember them a little bit easily. So you derive, you can derive them. And one more thing, one more important derivative, which was e power x. I told you I won't be deriving this because it's a lengthy derivation, and I'll derive it in some extra lecture, but not here. So derivative of e power x is e power x. Now if you use that, you can find the derivative of natural log of x also. Derivative of natural log of x is 1 by x. Okay, derivative of natural log of x is 1 by x. If you are interested, you can watch various videos on YouTube where they derive the they explain the derivation of these functions also, because this is not a math course. I'm not going into detail. Okay, they are very easy to derive, but we will not be discussing them here. Okay, so you have to remember this also, these two formulas also. So till now we have seen derivatives of functions. Okay, we have seen what derivative of y equals to mx plus c is. We have seen derivative of a constant function. We have seen derivative of x square, x cube, x power n, 1 by x, and one more derivative, if you can remember, it is derivative of root x. Derivative of root x is 1 by 2 root x. This also you can get. This formula also you can derive using the formula for derivative of x power n, and you'll get this, but it is better to remember this. It is better to memorize this, okay, because this function also appears quite a lot. Clear? This function also appears quite a lot in your problems. Okay, now let us just go back to the problem set. We'll discuss some problems, and then we'll come back to the discussion of integral calculus, which is also very important for us. Okay, now let me go back to the PDF. So let me see. Okay, so this is our PDF, the second PDF. So in the second PDF, this is the problem, first problem. In first problem, what is he saying? In the first problem, he's saying if f of x equals to x cube and g of y equals to y minus 1 and h of z is equal to z plus 1, then he's asking what is f of g of h of x. Okay, what is f of g of h of x? Okay, let us try to solve this. This is not a problem involving derivatives, but it is a simple problem relating to the topic of functions. Okay, but yet we'll derive this thing. Okay, okay, let me go back. So I'll just write down what the question is, and then I'll go back. So f of x is equal to x cube, g of y is equal to y minus 1, and h of z equals to z plus 1. Okay, then he's asking what is f of g of h of x. Okay, he's asking this. Fine. Okay, this is the question. So how to start this? So what is which function lies embedded inside? Okay, the function which is the innermost, it's h of x. Now here h of z is given. H of z is z plus 1, right? So what is h of x? H of x is x plus 1, because if z is z plus 1, then h of x is x plus 1. Z is replaced by x. So next, after that you have g of, what was h of x? It was x plus 1. So what is g of x plus 1? He has given g of y as y minus 1, implies g of x plus 1 is what? In place of y, you put x plus 1. So x plus 1 minus 1, which is equal to x, because this cancels. So what is g of h of x? It turns out to be x. What is g of h of x? It turns out to be x. Correct? Then what is f of x? Sorry, what is f of g of h of x? So what is f of g of h of x? We just found out this. G of h of x, it was x, so it is nothing but it's just x, so it becomes f of x. So what we need to find is f of x, which is what? X cubed, which is x cubed. Correct? Okay, so your answer is D. Your answer is D. So the answer is given in the paper itself. Okay, there is an asterisk here for the correct answer. Here there is an asterisk. So here you have an asterisk. So your answer is this. Clear? Okay, fine. Second question. Now this is the problem which is related to our derivatives that we just discussed in the last class and in the beginning of this class. So he's saying, he's giving one function. The function is what? Y equals to x cubed, second question, x cubed plus 2x squared plus 7x plus 8. Then he's asking what's dy by dx? What's dy by dx? That's the question, right? Okay, this is the question. So let us try to solve. It's quite easy. He's asking dy by dx. So there are, this y is sum of many functions. Okay, there are 1, 2, 3, 4 terms here. Okay, so you have to take the derivative of individual functions and add. So what is the derivative of x cube? It's 3x squared. Plus, what is the derivative of 2x squared? 2 you keep as it is. Derivative of x squared is 2x. You multiply. What is the derivative of 7x? You keep 7 as it is. Derivative of x was 1. So you write 1. And what is this? This is a constant function, right? You know the derivative of a constant function is 0. So what is dy by dx here? dy by dx is 3x squared plus 4x plus 7. So this is your answer. Okay. So let's check in the PDF. So we got 3x squared plus 4x plus 7. So where do you see here? That option in second question? It's option B. And that is what is given. That is what is given. Option B. 3x squared plus 4x plus 7. Clear? Okay. Next. Let's come to question number 3. Let's come to question number 3. Okay. Question number 3, he says, what does he say in question number 3? Let's see. Y equals to what? 1 by x power 4. Then he is asking what is dy by dx. He is asking what is dy by dx equal to. Okay, that's the question. So let me see. This is the question, right? So how can 1 by x power 4 be written as? It can be written as x power minus 4. It's in the form of x power n. So what is dy by dx? Use the formula for the derivative of x power n. It's n x power n minus 1. So it's this. So it turns out to be minus 4 x power minus 5. So it's equal to minus 4 by x power 5. So this is the answer. Minus 4 by x power 5. So let me go back to the PDF. So minus 4 times minus 4 by x power 5. So that's option 3. That's option C. Okay. So this is your answer. Correct? Okay. Next. Let me go to question number 4. Let me go to question number 4. In question number 4, he says, if y is equal to x square times sin x, which we already did, I think. Correct. With this problem we already solved. Then what is dy by dx? Then what is dy by dx? So what rule do you use here? Okay, this is the question. So what rule do you use? You use product rule, right? Why do you use product rule? Because this function is a product of two simpler functions whose derivatives we already know. So what's dy by dx? dy by dx is what? You keep x square as it is, you multiply it with the derivative of sin x, which is cos x. Plus, you keep sin x as it is, and you multiply it with the derivative of the other function, which is 2x, right? Derivative of x squared is 2x. So this is your answer. Okay. So your answer is x square times cos x plus 2x times sin x. So let us go to the PDF. Okay. So which option represents x square times cos x plus 2x times sin x? It is option A. Okay. It is option A. This option. Correct. So we have done with this also. Let's go to next question. Question number 5. Okay. Fine. Let me see what question number 5 is. Now question number 5 says y equals to e power x cot x. Again, we have product of two. Y equals to e power x times cot x. And is asking what is dy by dx. What is dy by dx? Is asking this. So that's our question, right? So let me go back to this. So this is my question. Again, here the situation where we need to use the product rule. We need to use the product rule. So y is a product of two functions whose derivatives we already know. So what is dy by dx? You keep e power x as it is, multiply it with the derivative of cot x, which I just told you is minus cosecant x times cot x. Plus, you keep cot x as it is and multiply it with the derivative of e power x, which is again e power x, because derivative of e power x is e power x. So what is the answer? Dy by dx. So there is something which can be taken as common, which is e power x times cot x can be taken as common here. So from the first term you get what? Cot x and e power x is gone, so minus cosecant x remains, plus here 1 remains because that comes outside. Okay, when it multiplies multiplies itself with 1, you will get that. So this is your answer. So what is your answer? E power x times cot x times 1 minus cosecant x, okay, or minus cosecant x plus 1. So let us see in the PDF which option matches. So in the PDF it's option C. The thing is, okay, he has not taken, oh sorry, what was the derivative of x? I made a mistake here. Cot x is the derivative of what? It was derivative of cosecant x. Let me redo it. So what was the derivative of cot x? It was minus cosecant square x. Minus cosecant square x. Derivative of cot x was minus cosecant square x. Let me just show you. Let me go back. Here we have the table. See, what was the derivative of cot x? It was minus cosecant x, minus cosecant square x. Derivative of cosecant x was minus cosecant x cot x. So I just messed up with this. So the correct derivative for cot x is minus cosecant square x. Okay, let me come back. So here we made a mistake. So I'm replacing it with minus cosecant square x. So now e power x, if I take common, what will I get? Cot x minus cosecant square x. This is your answer. Okay, fine. So if I go to PDF, our answer is e power x. See, let me go back. E power x times cot x minus cosecant square x. So e power x times cot x minus cosecant square x. So that option is option C. Option C. Clear? So we are done with this. Next, sixth question. Let me go to sixth question. Okay. So what does sixth question say? Sixth question says, if y equals to x ln x. What is ln? Ln is natural log. Log to the base e. Okay. If log is written anywhere, you assume that it is log to the base 10, unless there is e mentioned, in the subscript. So if just log is given, by default it is log to the base 10. If e is written specifically, then it is natural log. Otherwise, instead of writing log to the base e, they generally give ln. Okay, so this is y equals to x ln x. Then he is asking what is dy by dx. What is dy by dx? He is asking. Okay, let me go back. So this is the question. Okay, okay. So I think there is some lag here. Okay, now it's visible. So what is dy by dx? Now again we have product rule, right? Again we have product rule. This y is a product of two functions, x and natural log of x. So what is dy by dx? You keep x as it is and multiply it with derivative of log x or ln x, which is 1 by x, which I just told you. Plus, what is the so you keep ln x as it is and you multiply it with derivative of x, which is 1. So anyway, you get 1 plus natural log of x. Okay, you get 1 plus natural log of x. So dy by dx is 1 plus natural log of x. So let us go to the PDF and check which option is this. So 1 plus natural log of x, it's option B. If you see, it's option B, and it's given here. Option B is the answer. Next, let me go to question number 7. Let me go to question number 7. Okay. Question number 7 says, okay. Question number 7 says, if y equals to 4 plus 5x plus 7x cubed, then what is dy by dx equal to? That's question number 7. Okay, let me see. So this is the question, right? Now, again, a similar question. So dy by dx is, we have three terms here. So one by one, we have to find the derivatives and add them. So what is the derivative of 4? 4 is a constant function. Its slope is 0. Plus what is the derivative of 5x? 5 I'll write as it is. Multiplied with the derivative of x, which is 1. Plus 7 I'll keep as it is because it is a factor. And it comes out of the derivative. And what is the derivative of x cube? It is 3x squared. Okay. So what is dy by dx? Dy by dx is 5 plus 21x squared. 5 plus 21x squared. Correct? Okay. So, okay, fine. So 5 plus 21x squared. This is your answer. 5 plus 21x squared. Okay. So let me go back to the PDF. Which option is 5 plus 21x squared? It is option B. It is option B. 5 plus 21x squared. So our answer is correct. Right? So let me go to next question. Question number 8. Question number 8. In question number 8, what is he saying? In question number 8, what is he saying? He has given some function. Okay. He has given y equals to x plus x squared plus 1 by x plus 1 by x cubed. Okay, he's asking what is dy by dx. So dy by dx is what? That's the question. Okay, let me do it. So this is your question, right? Now, so I have to take the derivative of each and every term and then add. Okay, so dy by dx is, okay, let me take another color. So what is dy by dx? Dy by dx is, first I have to take the derivative of x. What is the derivative of x? It's 1. Plus what is the derivative of x squared? It's 2x. And what is the derivative of 1 by x? I just told you it's minus 1 by x squared. And what is the derivative of 1 by x cube? It's minus 3 by x power 4. You'll get it by using the formula for the derivative of x power n. Okay, because n is minus 3 here. So minus 3 times x power minus 3 minus 1 is x power minus 4, which turns out to be this. So what is dy by dx? Dy by dx is 1 plus 2x minus 1 by x squared minus 3 by x power 4. This is your answer. So let me go back to the PDF and check. Okay. I think there is a lag here again. Okay. Okay. Anyway. Okay. Let it load. There is a problem in the network, I guess. Okay. This is your answer. 1 plus 2x minus 1 by x squared minus 3 by x power 4. So let me come here and see which the option is. So 1 plus 2x minus 1 by x squared minus 3 by x power 4. That is the answer. Okay. So, okay. A. Okay. So option A is 1 plus 2x minus 1 by x squared minus 3 by x power 4. Yeah. Okay. Let me just try to use some other okay, let me okay, I'm just switching the okay, fine. Okay, I'm just switching the app. That app mirroring app is not working, so I just switched up the app. Okay, fine. Clear. So this was your derivative. Let's go to the next question. What is the next question? It's question number 9. Okay, question number 9. If f of x is equal to x cube times ln x. Okay, let me write the question down. If f of x is equal to x cube times natural log of x, what's dy by dx? Or he has written what is f dash of x. So some question is something like this. It's given in a different style. Okay, the question is actually given in a different style. Instead of giving y, he has given f of x. I told you dy by dx was a notation introduced by Leibniz, and f dash of x was a notation given by Newton, or f prime of x is a notation that was introduced by Newton. So but they mean the same thing. Okay, so what does f dash of x mean? It's nothing but dy by dx. Okay, so let us try to take the derivative here. So it's again a question that involves product rule. So f of x is a function of two functions, product of two functions. So I'll keep x. So I need to find dy by dx, or in this case he's saying f dash of x. So I'll write f dash of x. So f dash of x is a derivative of, you keep first function as it is and you multiply it with the derivative of second function, plus you keep the second function as it is and you multiply it with the derivative of first function, which is derivative of x cubed, which is 3x squared. Okay, so what you get is x squared plus 3x squared natural log of x, and if you take out x squared as common, so you get 1 plus 3 natural log of x. Correct? Fine. Okay, so the answer is x square times 1 plus 3 natural log of x. X square times 1 plus 3 natural log of x. So he didn't take out x square as common in the options. He just left it as it is. So the answer is this. Okay, it is this. So anyway, the answer is same. Next, let us go to question number. Let us go to question number 10. Now in question number 10, he has given one function. He has given one function. F of x equals to x plus 2 by x minus 2. Find the value of f of minus 1. That's the question. It's very simple question. So let me try to just answer this. So I'm going back to the pad. Okay, fine. Okay. Okay. Now, how to do this? It's quite simple. You just substitute minus 1 in place of x. So what do you get? F of minus 1 equals to minus 1 plus 2 by minus 1 minus 2, which is equal to 1 by minus 3. So minus 1 by 3 is your answer. Minus 1 by 3 is your answer. So option is option B in question number 10. Now let's go to question number 11. Okay. So what is question number 11? Question number 11 states, asks, if y equals to x square plus 1 by x squared, find dy by dx. Find dy by dx. Okay, that's the question. So this is the question. So it's quite easy. Again, dy by dx equals to, first I'll write the derivative of this. What is derivative of x squared? It's 2x. Plus what is the derivative of 1 by x squared? It's actually minus 2 by x cubed. You'll get this by using the formula of derivative of x power n, which is n into x power n minus 1. So it is x power minus 2. So the derivative is minus 2 times x power minus 2 minus 1, which is minus 2 x power minus 3, which is this. Okay, so your answer is this. Dy by dx equals to, if you take 2 common here, you'll get x here and minus 1 by x cubed. So answer can be written something like this. Let us see how the answers are given in question number 11. So answers are given. He hasn't taken 2 as common. So your answer is 2x minus 2 by x cube. 2x minus, so here it is, if you multiply 2 and multiply each term with 2, it becomes 2x minus 2x by 2 by x cube. 2x minus 2 by x cube. So 2x minus 2 by x cube. It's option A. It's option A. Clear? Okay. Let us go to next question. Question 12. Okay. In question 12, what is he asking? In question 12, if f of x is equal to sine square x minus cos square x, then find f of pi by 4. It's quite easy. Just substitute pi by 4 and you'll get the answer. Just substitute pi by 4 and you'll get the answer. So let me go back. Okay. So question number 12. If f of x is what? Sine square x minus cos square x. What is f of pi by 4 equal to? That's the question, right? So this is the question. So you can do it directly. You can just substitute pi by 4 and you'll get the answer. So it's sine square pi by 4 minus cos square pi by 4, which is what? What is sine pi by 4? 1 by root 2. What is sine square pi by 4? It is 1 by 2, because root 2, if you do square for root and square cancel. So it's 1 by 2 minus 1 by 2. So I think the answer is 0. Answer is 0. Is the answer 0? Yeah, I think answer must be, yeah, let me see what is he asking actually. Is he asking f of pi by 4 or f prime of pi by 4? I think he's asking f prime of pi by 4, not f of pi by 4, because he's giving answer as 2. What do you mean by f prime of pi by 4? It is a derivative of f of x. So let me see what is whether he's asking f prime or f. I think he's asking f prime, because there is a prime which is very small. It's not visible clearly. So let me see. Let me find f prime. Okay. So if f of x is sine square, let me write again, sine square x minus cos square x. Okay, let me come back. So this is f of x. So what is f dash of x? I can do it directly, but I have a better way. First I'll write f of x as cos 2x or minus cos 2x, right? It is equal to minus cos 2x. What is cos 2x equal to? Let me write down here. Cos 2x is equal to cos square x minus sine square x, which we already derived, right? So what is minus of this? Minus of cos 2x. Minus of cos 2x is what? It's sine square x minus cos square x. Correct? So how can this be written as? This can be written as minus of cos 2x. Nothing, just it will be easier. So if f of x is what? If f of x is if f of x is minus cos 2x, then what is f dash of x? F dash of x is how much? So let us keep minus as it is. Okay. And what is the derivative of cos 2x? It's minus sine 2x, because derivative of cos x is sine x. But in place of x, what do you have? 2x. So I have to apply chain rule. So the derivative of 2x is 2, which I have to multiply. So your answer is minus minus becomes plus. So it is 2 sine 2x. 2 sine 2x. So you got derivative of 2 sine 2x. Now this is f dash of x. He is asking what is f dash of pi by 4, right? So you substitute pi by 4 here. What will you get? Sine of 2 pi by 4, which is 2 sine of pi by 2. What is sine of pi by 2? Sine 90 degrees is 1. So your answer is 2. So in the question he is not asking uh, f of pi by 4, he is actually asking f prime of pi by 4. That's why the answer is what? 2, not 0. So there is f prime here. If you see, if I zoom, I am able to see. I don't know if it's visible on the screen or not, but there is f prime. So I didn't see that, and I directly calculated f of pi by 4 first, when I got, that's why I got 0. But he's actually asking f prime of pi by 4. So answer is actually 2. Correct. Next. Now he is asking questions related to physics. Now till now we had practice of what? Derivatives. Okay, we had practice of derivatives. We have used formulas for different derivatives. We have used formulas for different derivatives. We have derived derivatives for various functions. We learned how to use product rule and chain rule, and using product rule and chain rule we found out derivatives of some more important functions. Okay, and we used it. Now in physics, you can apply derivatives to find various physical quantities. For example, the derivative of displacement is velocity, and the derivative of velocity function gives you acceleration function. Okay, and all this displacement, velocity and acceleration, for example, displacement, velocity and acceleration, the symbols of displacement is s, the symbol of velocity is generally v, and this symbol of acceleration that we generally use is a. These are all functions of t. These are all functions of time. Till now we were assuming that y is a function of x, okay, because that was mathematics. But in physics, on the x-axis or on the horizontal axis, you don't take variable as x, you take variable as t. Because in physics, what do? In physics, you find how things change with time. Okay, you write everything as a function of time. You write everything as a function of time. Okay, you use the laws of physics and you write down, you derive the expressions for how the displacement of particle changes with time, how the velocity of the particle changes with time, how the acceleration of a particle changes with time. So you represent displacement as a function of time, velocity as a function of time, acceleration as a function of time. Okay, if acceleration is constant, or in case of uniform motion where acceleration is constant, acceleration doesn't change with time, it's just constant. But there are cases where acceleration can change with time. We say that acceleration is variable there. Okay, now we'll discuss about this right now. Okay, let me see. uh, so let us begin. Let me begin actually. Okay, let me begin by let me begin by a topic of you know kinematics. So basically kinematics is study of motion. Okay, now the most important part of kinematics for you is problems involving uniform motion. Uniform motion. Now any particle can have motion either in one dimension, or it can have motion in two dimensions, or it can have motion in three dimensions. Now what is the best example? What is the best example of motion in one dimension? What is the best example of motion in one dimension? Any freely falling body is an example of motion in one dimension. Okay, because if you drop something, they fall in a straight line, they go towards the center of earth. Okay, that is one dimensional motion. Okay, let me write down. So one dimensional motion. So example, freely falling body. Okay, next. Okay, this is a separate thing. Just focus on the green part. We are discussing about dimension, uh, how motions, different kinds of motion are divided depending on the way they move in the dimensions or in space. So if they move only in one dimension, it is called one dimensional motion. The best example is any freely falling body. Second, two dimensional motion. Two dimensional motion. This one dimensional motion is also called, this one dimensional motion is also called, this is also called motion in a straight line. And two dimensional motion is also called motion in a plane. Motion in a plane. This is also called motion in a plane. Okay. Now, what is the best example of motion in a plane? The best example is projectile motion. Okay. When you project something at angle other than uh, you know 90 degrees with horizontal, or if you project anything which is not in which the initial velocity is not in vertical direction, then it will move in a parabolic path. We'll study about that, but that's called projectile motion. Projectile motion. So projectile motion is a motion in two dimensions. That means all, if you take the trajectory of the particle that is in projectile motion, it will lie in one plane. It will lie in one plane. It won't come out of that plane. Okay. So it will fit into one plane. So that's why it is also called motion in a plane. That's why it's also called motion in a plane. Now third, three-dimensional motion. What is the best example of three-dimensional motion? Three-dimensional motion. Three-dimensional motion. The best example of three-dimensional motion is when a ball swings. Okay, when someone kicks a football, or if you have uh, a pace bowler in cricket or in baseball, they swing the ball. That means the ball will move from left to right and right to left because of uh, air drag, because the ball spins and it moves from left to right and right to left. How it spins, why it spins, we'll learn about that in fluid mechanics when we learn Bernoulli's theorem. Okay. Uh, so that motion is the best example of three-dimensional motion. Okay. When you kick a football and if it is swinging, if you do a banana kick, it will not only acquire a parabolic path in vertical and horizontal direction, but it will move in other dimension also. That means the displacement of ball is not only in upward and downward direction, forward direction, but it is also on the left and right. So it will take a 3D path. Okay, that means you cannot draw a plane in which this trajectory fits. You cannot draw a plane in which this trajectory fits because it will come out of the plane. Okay, so this motion is called three-dimensional motion, and the other name for this three-dimensional motion, you might have already guessed, is motion in space. Motion in space, because we live in a three-dimensional space, right? We exist in three-dimensional space. As far as we know, we live in three-dimensional space. Okay, this is three-dimensional motion. I will discuss three-dimensional motion a little bit at the end of the chapter, but mostly uh, kinematics is concerned with one-dimensional motion and then two-dimensional motion. Uh, so these first two kinds of motion you'll study in detail, and third is rare. Problems are rare, but anyway, I'll discuss a couple of problems in three-dimensional motion also. Okay. Now this is about the space. If you see how the particle is moving in space, we can divide this into three categories. Now let us talk about uniform and non-uniform motion. So let us stick to one-dimensional motion. So let us stick to one-dimensional motion. Let us stick to one-dimensional motion. So now in one-dimensional motion, we assume that particle is moving in a straight line. So we forget about the two-dimensional and second dimension and third dimension. Now we stick with this. Okay. Now there are two kinds of motion here. One is called uniform motion. The second is non-uniform motion. Very important. Now in uniform motion, acceleration is constant. Acceleration doesn't change, or acceleration is not a function of time, it's a constant value. Acceleration is fixed. It can be anything. It can be 1 meter per second square. It can also be 0 meters per second square. That means even the particles moving with uniform velocity have zero acceleration, and zero is also a constant. So, and even the particles at rest have zero velocity and hence zero acceleration, and hence every particle at rest is also in uniform acceleration. Every particle is at rest is in uniform acceleration, every particle moving with constant velocity is in uniform motion, and every particle moving in with a constant acceleration is also in uniform motion. Whereas non-uniform motion, acceleration, in non-uniform motion acceleration changes, or acceleration is variable. Acceleration is variable. What is meaning of variable? It changes. It changes with time. That means acceleration is a function of time. It can be any function. It can be sin t, it can be cos t. For example, in simple harmonic motion, acceleration changes with time. Okay, at extreme positions acceleration is maximum, at mean position acceleration is zero. So acceleration is changing, right? So simple harmonic motion is the best example of your non-uniform motion that you will come across. It's a separate chapter, and there are lots of things you need to learn in simple harmonic motion. What is the best example of uniform motion? So let me write here. Let me write here. So the best example of non-uniform motion is SHM. Example, SHM. The best example of uniform motion is again freely falling bodies. Freely falling bodies, or bodies which are projected vertically in the upward direction, or even actually projectiles are also in the, projectiles, if you see, they also have constant acceleration, right, which is vertically downward. No matter, their path is in two dimensions, but the acceleration is always vertically downwards. Even projectile motions are, you know uh, a kind of uniform motion. They come under the category of uniform motion, but we are not discussing about two-dimensional motion. We are discussing about one-dimensional motion here. So I'll stick to vertically projected body, or a body that is freely falling, or which is dropped from certain height. Okay, and that height must be not very high. That means height should not be equal to radius of Earth. Height should be negligible compared to the radius of Earth, because if you go at very high place or at a very high altitude, which is of the order of radius of Earth, then again acceleration will change when it comes from top to bottom. So in that case it will not be uniform. Okay, in order for uh, acceleration to be constant, the heights from which you drop the bodies should be very small compared to radius of Earth. You keep that in mind. Okay, so these kind of questions can be asked. These are all theoretical kinds of questions. Okay, so if he says a body is dropped from a height equal to radius of Earth, that means 2r from the center of Earth, is that freely falling body an example of uniform motion? Answer is no, because when it comes from height, distance of 2r from the center of Earth to a distance of r from the center of Earth, the acceleration will change. Actually, acceleration will become 4 times. You will see in the chapter of gravitation. But if you drop any body from small heights, where height is much less than r, then you assume that g is constant throughout, and that is, considered to be uniform motion. Now, because see, most of the experiments initially done by Galileo were what? Dropping something from Leaning Tower of Pisa and coming to certain conclusions through the observation. All those experiments were what? Based on freely falling bodies from small heights. That's why this chapter is so significant for you. Now, let me come back to uniform motion. So, what is the meaning of uniform motion? Okay. So uniform motion, A is constant. So uniform motion is constant. Now, what is velocity? Velocity is rate of change of displacement. So change in displacement by change in time gives you velocity. Okay. So here this is actually instantaneous velocity, because at any instant of time you can find the velocity as a function of time. What is acceleration? Acceleration is rate of change of velocity. Change in velocity by change in time gives you acceleration. Okay. So this is acceleration. Now here you can conclude one thing. If you have a displacement time graph, time versus displacement graph, because the derivative gives you slope, the slope of displacement time graph is what? Velocity. Okay, let me write in another color. So the slope, because what is derivative? Slope. So slope of displacement time graph gives you velocity. Okay. And if you have velocity time graph, okay, then slope of velocity time graph gives you acceleration. Slope of velocity time graph gives you acceleration. Clear? You have to remember this. Now, so these are important terms. Now I'll go back to uniform motion. And I'll focus on velocity time graphs. I'll focus on velocity time graphs. So this is your time versus velocity. That means velocity plotted as a function of time. Okay. Now suppose the graph is a straight line like this. So what does a straight line signify? Straight line signifies constant slope. That means slope of this graph is constant everywhere. What is the slope of velocity time graph? It's acceleration. Slope is acceleration. I'll write slope is A. Okay. Now if slope of velocity time graph is constant, acceleration is constant. If slope of velocity time graph is constant, acceleration is constant. Correct? That means this is uniform motion. This is uniform motion. Now next, what if slope of velocity time graph not constant? For example, if the curve is like this, now the slope is what? Slope is changing, it is increasing, right? So slope is variable. But what is slope? What is slope? Slope is acceleration, right? In velocity time graph, by A is equal to dv by dt. So it's the derivative of velocity, that means it's the slope. Now slope is changing. If slope is changing, this is a non-uniform. Slope is changing, acceleration. Okay. So this is, if the graph of velocity time graph is, slope is constant. If slope is constant, acceleration is constant, because acceleration is the slope in velocity time graph. Why? Because A is equal to dv by dt, which is nothing but slope. Okay. So this is uniform motion. This is non-uniform motion. Do you agree? Okay, fine. Good enough. Now, what about this? Time, velocity, and if the graph is like this. Okay, let me draw in other color. If the graph is like this, horizontal. Okay, let me draw correctly. This is horizontal graph. So what is happening here? Slope is zero everywhere. Slope is zero everywhere. But still it's constant, right? Zero is also a constant. So acceleration is zero in this graph. Acceleration is zero because slope is acceleration. So is this uniform or non-uniform? It is uniform because acceleration is constant. Acceleration is constant, correct? So anything moving with constant velocity is also uh, an example of uniform motion. What about this graph? Time versus velocity. And if the particle is at rest, suppose if the particle is at rest, velocity will be zero, right? So the graph will be like this. It will be zero. Graph will be something like this. Now still, what velocity is zero, value is zero, as well as slope is zero of this function. Value is zero as well as slope is zero. If slope is zero, acceleration is zero. If acceleration is zero, this is also uniform motion. That means everything at rest is also an example of uniform motion. Okay. When the motion will be non-uniform, motion will be non-uniform only when you have a curved line in velocity time graph. If you have a curved line, then slope here, 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 everywhere is different. Slope is changing. So acceleration is changing. Therefore, it is an example of non-uniform motion. Clear? Okay. Let me come back to uniform motion. Now, if you have uniform motion, if you have a straight line, you need not take the derivative. You can use the formula of what? y2 minus y1 by x2 minus x1 to find the slope. y2 minus y1 by x2 minus x1 to find the slope. So, okay, let me begin my observation. Okay, I'll draw the graph like this of uniform motion. This is the velocity time graph, suppose. This is the velocity versus time graph. Okay, I will begin my observation at t is equal to 0. So at t is equal to 0, the velocity is called initial velocity and it is represented by u, correct? And at t is equal to some other time, say at t is equal to t, at time t, you have final velocity. So this value is what? Final velocity. This is final velocity. I'll just erase it. So this is your final velocity. Are you understanding? This is your initial velocity and this is your final velocity. Now if you want to write the ordered pairs, what will be the ordered pairs? So what is x here? 0, because time is 0. And what is y here? It is u. So x comma y is written as 0 and u. Here how will you write x comma y? X is t here because x is t, and what is y here? Y is v. So instead of xy axis we have t versus v axis. That's why you have 0 comma u as your first point and t comma v as your second point. Now what is the formula for slope? Now I can take any 2 points on a straight line and find the slope. I need not find the derivative. I need not use the formula for derivative. I can use the formula of derivative, but here it is not required. Even by that formula we will do and see. So what is the formula for slope? y2 minus y1 by x2 minus x1. What is y2? V. What is y1? U. By x2 minus x1. What is x2? T. Minus what is x1? 0. So this is slope. But what did I tell you slope was? Slope of any velocity time graph was. It was equal to acceleration, right? So what do you get from this? You get v minus u by t equals to a. Okay. That means you get v minus u equals to at, implies v equals to u plus at. This is your first equation of motion. This is your first equation of motion. And this is true only for uniform motion. This is true only for uniform motion, because if you don't have uniform motion, you don't have a straight line, and if you don't have a straight line, this formula is invalid. y2 minus y1 by x2 minus x1 is equal to slope. This formula we used to derive this. So this formula is valid only for straight lines. So this equation is only valid for uniform motion, because you get a straight line in velocity time graph only if acceleration is constant, correct? So this equation is valid only for uniform motion. So v is equal to u plus at. We derived our first equation, v equals to u plus at. This is true for uniform motion. or true if A is a constant. Correct? Okay, next. Let us go to our next equation. Now, I didn't discuss integration with you. I'll discuss in the next class. And using integration also, we will derive these equations. But because now integration hasn't been discussed, I'll derive other equations in some other way. Now, if you have any, okay, this is time versus velocity. If you have any value that is increasing uniformly, for example, v is increasing uniformly here. If it is straight line, v is increasing uniformly. If it is a curve, it is changing non-uniformly. Then suppose this is your initial time 0 and this is your final time t. So this value is u and this value is, okay, I'll just rewrite it. This value is v. Okay. So if the situation is like this, then the average velocity between time 0 and t, average velocity can be found out by what? V average, which is written as V bar, initial value u plus final value V divided by, 1 second. Okay. Okay, let me come back. Yeah. Okay. Initial value plus final value divided by 2. Okay, if something is increasing uniformly, then its average value can be found out by adding its initial value and final value and dividing it by 2. Okay, this is true only for what? Any values that are changing uniformly. I'll give you an example. Suppose you are in a class, okay, and there are 100 students in class, and first student got 1 mark, second student got 2 marks, third student got 3 marks, fourth student got 4 marks, and you add all the marks of the students. So the 100th student got 100 marks. And if you want to take the average of the class, you add all the marks and you divide by 100. Now here the marks are uniform because everybody is getting, 1 mark increment compared to the previous student. So marks are, the marks that the students have obtained is uniform here. Okay. Now, for example, if 10 students got 1 mark, 40 students got some 13 marks, and some 20 students got 91 marks, this kind of situation is non-uniform. So everybody is getting different marks. There you have to add all the numbers and you have to divide by number of students to get the average value. Here also you can add all the marks and divide by 100 to get average value, but I will give you a trick. See, what is the sum of first 100 numbers? It is 100 times 101 divided by 2. Sum of first 10 numbers is what? N into n plus 1 by 2. This formula you learn in school. This was given by Gauss. He gave this formula when he was in class 5. Okay. When his teacher asked him to count all the numbers from 1 to 1000, he immediately answered the question. And when the teacher came, the teacher was surprised. How did he add all the numbers from 1 to 1000 in such a small duration? He said it's quite easy. Take x equals to 1 plus 2 plus 3 plus all the way to 1000 he has taken. I'm taking it n here. And then here he told take it again but write in reverse order. So n comes first, n minus 1 comes next, then n minus 2 comes, and so on, add, and at last you will get 1. So for example, 1 to 1000 he writes in increasing order first, and then he writes in decreasing order. So 1000 plus 999 plus 998 and so on. And if you add this, you'll get 2x here, and here you'll get 1 plus n. If you add these two, you'll get again 1 plus n. If you add these two again, you'll get 1 plus n, and so on. You'll get this. When you add, you'll get 1 plus n. How many 1 plus n's you get? Because there are 1000 terms, you'll get 1000. Okay, if there are n terms, you get n into n plus 1 equals to 2x. So what is x equal to n into n plus 1 by 2. So this is the way in which you derive the formula of what? Sum of first and natural numbers. Clear? So here, see, n into n plus 1 divided by 2 is what? This divided by this 100. So what remains? This 101 by 2 is your answer. So actually it's first number plus last number divided by 2. 1 plus 100 by 2, which can give you average value. Correct? Here also, if you have n values, what is sum of n values? N into n plus 1 by 2. And if you want to find the average, you have to divide by total number of values, which is n. And what you will get? 1 plus n by 2. So this is first number plus last number by 2. So whenever you have uniform distribution or uniform increment in values, you can find average value by taking the initial value, adding the final value, and dividing it by 2. This is true only if the value is changing uniformly. If it is non-uniform, it is not true. That means this equation is true only for uniform motion. Again, this equation is not true for non-uniform motion. This equation is not true for non-uniform motion. Clear? Okay. So we derived one formula already, which was V equals to U plus AT. This we already derived. And I just now said that average velocity is equal to initial velocity plus final velocity divided by 2. Okay. Next, one more thing. What is displacement by time? Total displacement by total time. Total displacement by total time is average velocity. It's not initial velocity, it's not final velocity, it's average velocity. Total displacement by total time is what? Average velocity. So if the displacement of the journey is s and total time of the journey is t, then average velocity is given by s by t. Clear? Okay, you have this equation. So what is s equal to? S equals to average velocity into time. Average velocity into time. Now, if I want to eliminate a t in this equation, what will I do? I'll write s equals to, I'll write in place of average velocity v plus u by 2 or u plus v by 2. And what is time? If I want to eliminate time here, what is time? So it is v minus u by a equals to t, right? If I send u to the left hand side and if I send down, you'll get t equals to v minus u by 2. So you'll get v minus u by v minus u by a here. So what will you get? S equals to v square minus u square, because a plus b into a minus b is a square minus b square by 2a. So we conclude that 2as equals to v square minus u square. Now why did I eliminate t here? Because I wanted to find this equation which doesn't contain t. So somehow I have to eliminate t. So here I used this to eliminate t and I got the answer. Clear? Now next. So I got the second equation of motion. This is also true for only uniform motion. This is true only true for uniform motion. Uniform motion. What is the meaning of uniform motion? Any motion that has constant acceleration. Why? Because this formula was true only for uniform motion and this formula was true only for uniform motion, and we use these two formulas to derive this formula. So obviously that is also true only for uniform motion. Clear? Okay. Next, I'll derive the other formula, s equals to ut plus half at square. I'll take different color. So again I'll come back. So what is displacement equals to? Average velocity into time. Correct? Now what is average velocity? V plus u by 2 or u plus v by 2 into time equals to s. Now using this I need to derive this, s equals to ut plus half at square. Now if you observe in this equation there is no v. There is no v. So somehow I have to eliminate v. How will I eliminate v? I know already that v is equal to u plus at. So I'll use that. Okay. So in place of v, what will I write? In place of v, what will I write? Okay, let me fine here. In place of v, what will I write? U plus at. So in place of v, I'm writing u plus at. Okay, plus u by 2 times t equals to s. Okay, so what is s equals to? U plus u is 2u plus at divided by 2 times t. What will you get here? 2u by 2 is u plus half at times t. So it's ut plus half at square. S equals to ut plus half at square. So this is also true only for, this is also true for, true only for uniform motion. This is not true for non-uniform motion. Okay, so these three formulas that we just derived, the first was v equals to u plus at. Second was v squared minus u squared equals to as, and third s equals ut plus half at square. These three equations are valid only for uniform motion. So which is the best example of uniform motion? Freely falling bodies. Okay, so these equations are true only for uniform motion, and it can be applied for freely falling bodies, which we will do. Clear? Okay. Now let us go to the topic of integration. Let us go to the topic of integration. Okay, now listen carefully, this is very, very important. I'll tell you what integration is first, and I'll tell you why the formulas for integration are the way they are. Okay, so suppose you have any function f of x, y equals to f of x. Clear? This is some function and it is a non-linear function. Okay, non-linear function, that means it's not a straight line. Now how do you write integration as? Integration you write something like this. First in integration you have f of x times dx. So what is the meaning of f of x? So this is f of x, right? So if this is x, this is f of x. Okay, let me write here. So this is the value of what? F of x. If this is x, this is the value of f of x. Now what is the meaning of f of x times dx? So f of x is the length of this line, okay, times dx. So let me take dx in white. So times dx is what? Dx is this small change in x. So f of x dx is actually length into breadth of this triangle. So you'll get the red area here. Okay, so this f of x dx, okay, let me write in red color. So f of x times dx is this red area. Do you agree? And actually that rectangle is very thin. I am drawing it little wider because it will not be visible. It will almost be like a straight line, a small, you'll have a very small negligible width, very thin triangle you'll have. Area of this rectangle. Now you put this symbol beside this f of x dx, which is actually a stretched s. Okay, it is actually a stretched s. It looks like s, but it is stretched little bit. Okay, so what does summation mean? That means it is sum of certain values, and you put limits here, a and b. Lower limit is a and upper limit is b. Those are the limits of x. So x starts at a and ends at b. So actually when you write this, you will have summation of all these rectangles, summation of all these rectangles with areas f of x times dx, which lie between limits a and b. If you add those, you will get what? The value of this integral. This is the integral you are intending to find. So what does integral of f of x dx between a to b indicate? It is the area bounded by the graph x-axis and two vertical lines x equal to a and x equal to b. That is integration. Okay, that's what integration is. Now let me just try to tell again what I just said. Okay, so if you have any function x and here y equals to f of x, and if that function is non-uniform, suppose it can be uniform also, but general case it is non-uniform. Okay, then at any point x, this is the value of x, that means x is actually from here to here, this is the value of x, it will correspond to some y which is equal to f of x. That means what is the length of f of x? This is the length of f of x, or the value of f of x is this, because that is what y is. So times dx, so this is dx, gives you this rectangle, and length into breadth, length is f of x, see this length is f of x and breadth is dx, so f of x into dx gives you this area. So f of x let me write in red. So what is f of x dx? It is area of this red rectangle. Now if I integrate it or put a summation here, and if I put the limits a and b, then it will give me the sum of all areas of all these kinds of triangles which lie between a and b and x-axis. So this is x-axis, so let me write down in blue, this is your x-axis, this is your function, and these are two vertical lines, x equal to a and x equal to b, and you will get this total area which is actually equal to sum of areas of all the small rectangles. Okay, now area can be positive or negative, area can be positive or negative. Let me explain what area, positive or negative. So I'll try to explain what I'm saying. So if function is something like this, okay, now if you integrate this between these two limits, then you'll get a negative area. You know why? Because dx is anyway positive, but f of x is what? Negative here. F of x is negative. So negative times positive gives you negative. So all these areas will be negative and they will add up and give you negative area. But this area is negative. But if the limits are here to here in integration, then this area will be positive. Here f of x times dx will be positive everywhere. Here positive, here positive, here positive, because f of x is positive everywhere. And if you do integration here between c to d, let me call it c, let me call it d, this will be positive. And here if the thing is a and thing is b, and if you integrate from a to b, this will be negative. Clear? Sometimes it can be 0 also. For example, if you have a function like this, and if the limits are from here to here, from e to f suppose, and coincidentally if the magnitudes of these two areas is equal, but they have opposite signs, so they add up and give you 0 area, e and f. So integral of this some other function g of x dx between e to f is what? 0. Here this is 0. Clear? So basically what is integration? Integration is what? Area under the graph. In simple words, it is area under the graph. You have to remember this because it will be used in problems. In problem sets, I'll also derive those three equations: v is equal to u plus at, s equals to ut plus half at square, and v square minus u square is equal to 2as, using integration and differentiation. And you will be using those kinds of methods in solving some problems which are not uniform motion, because in uniform motion or acceleration is a function of displacement, that means acceleration is not constant, then you cannot use those three equations. If you use those three equations, you'll get wrong answer. Differentiation to solve that kinds of problems, those kinds of problems. Clear? So now it says that integration is opposite of differentiation, that means formulas are opposite. what has integration got to do with differentiation? So what was differentiation? Differentiation was f of x plus dx minus f of x by dx, which was equal to dy by dx. So dy was change in y, dx was change in x, and dy by dx is nothing but slope, delta y by delta x, y2 minus y1 by x2 minus x1. So this will give you slope. Differentiation is slope of a function. Integration is area under the curve of any function, or area under the curve of any function. And they say that both are opposite to each other. What has got to do with area? It makes no sense initially, right? But I will prove it. I'll prove what integration is. First, I'll tell you how to find integration of certain functions, and then I'll tell you why that thing works. Okay, first let me define how to find integration. Suppose you have any function of x from a to b. You first write the integral. See, you write derivatives, right? What is derivative of sin x? Cos x. What is derivative of cos x? Minus sin x. What is derivative of natural log of x? It is 1 by x. What is derivative of e power x? It is e power x. What is derivative of x power n? It is n into x power n minus 1. So you write derivatives. In the same way, there are formulas for integrals, okay, which I will discuss just now. But the integral I'll write. Now the function is small f of x, and the integral of that function is capital F of x. Okay, so integral. So I'll write it here just to make it clear. Capital F of x is integral of small f of x. Capital F of x is integral of, okay, capital F of x is integral of small f of x. Clear? So here I'll write f of x first, and then I'll put a square bracket around it, and I'll put the limits a and b. And to finally get the answer, I should substitute value of b and a, and I should subtract lower limit from the upper limit to get the answer. Okay, I should subtract lower limit from the upper limit to get the answer. I'll just explain what it is first, and then I'll tell you why it works. Okay, I'll just explain with the help of one example. Now integral of 2 to 3, okay, x square dx. I need to find this. Okay, so first I write integral of x square. Okay, I'll give you the list of formulas, but you might already have some idea about integrals. So x power n's integral is x power n plus 1 by n plus 1. See, differentiation of, what was differentiation? So this is integral. What was differentiation? What was derivative of x power n? It was n into x power n minus 1, right? But the integral is different. Integral is x power n plus 1 by n plus 1. Generally, students get confused with the formulas. When they ask integral, they write derivative. When derivative is given, they write integral. So I'll just clear it up first, but let me just explain with the example. Now here what to do? First I'll write the integral. Integral is x cube by 3 according to our formula, x power n plus 1 by n plus 1. And I'll put the limits from 2 to 3. What is upper limit? 3 cube by 3 minus what is lower limit? 2 cube by 3. So what will you get? 3 if you take common, 2 cube is 27 minus 8, which is equal to what? What is 27 minus 8? I think 27 minus 8 is 15, right? Not 15. 27 minus 8 is how much? 19. So 19 by 3 is your answer. 19 by 3 is your answer. Correct? So again, I'll give you one more example. Integral of x square from 4 to 5 dx. So first I write integral of x square. What is integral of x square? It's x cubed by 3. I'll put the square brackets. 4, 5. So it's 5 cube by 3 minus 4 cube by 3. So whatever it is the answer. So this is how integrals are formed. Now let me come back. So if you want to find the integral of any function, small f of x dx between the limits a and b. First I write capital F of x, which is the integral. I'll put the limits from a to b and I'll subtract lower limit from the upper limit. Clear? Okay, fine. Now, here, what was capital F of x? Capital F of x was integral of small f of x. Okay? Now, then he continues this. He says, such that derivative of capital F of x is small x. What does that mean? See, this is the integral, right? So if you take the derivative of capital F of x, you'll get this. So this is the derivative. This is the derivative. Clear? I'll try to explain what I just said. So what was integration of x square dx? Say from a to b, whatever it is. It was, first you write x cube by 3 and you put the limits a to b. Okay, fine. But see, the derivative of x square was x cubed by 3. Okay. Sorry, the integral of x square was x cubed by 3 such that the derivative of this is this. This formula is given that the derivative of this is this. Let us check it. If you take out the derivative of x cube, what do you get? So 1 by 3 I'll keep as it is. Derivative of x cube is what? 3x squared, right? So you got x square. So you got this. You are understanding what I am trying to say? I am repeating this. Derivative and integral are opposite to each other. If you take out the integral of a function and you take out the derivative again, you'll get it back. Okay, so derivative of x cube by 3 is x squared and integral of x square is x cube by 3. Okay, so that's the thing. So if I write the statement again, okay, I'm writing the statement again. How to find the derivative? Okay, I'll write the statement again. How to find the integral? That's the question, right? Integral of integral of f of x dx from a to b. First you write the integral f of x from a to b and then you subtract the lower limit from the upper limit by substituting f of b minus f of b minus f of a. Okay, fine. Such that, I'll continue, such that derivative of capital F of x is small f of x. Derivative of capital F of x is small f of x. Okay. Now, let us prove this. Let us prove this. The statement, let us prove. So watch carefully. After this, everything will be easy. This is the last mathematical derivation that you are doing. Okay, don't worry. After that, we will begin our physics. If you understand this, you will understand many things later. Now, I want to take out the derivative. The limits are from a to b of this function. That means I need the area bounded by these red lines, yellow line and white line. Okay. So how will I write? This is f of x, right? Y equals to f of x and this is x. So how will I do it? I'll put f of x dx, which will give me what? This area f of x into dx, because this length is f of x and this breadth is dx and this is x. This is dx. So this is x plus dx. So dx is the breadth and length is what? What is the length of this? So this is f of x, right? This is f of x. So this length is f of x. So this length is f of x. So f of x dx is this yellow area, correct? And I put summation of all such areas between a and b to get all the area, this area, this area. Fine, not a problem. Okay, so what was the thing? You should write integral first, capital F of x from a to b, and subtract this from this, such that in derivative of capital F of x was small f of x. So I need to prove this. Okay, so anyway, so let me draw this again. Okay, let me draw this again. Okay, so let me draw this again. Now, this is A, this is B, and this is some x in between. This is some x in between. Okay, now I'll define a region R of x such that it gives me the area between x is equal to a and x is equal to x. So R of x gives me this. R of phi gives me area, okay, till here. So if x is here, I'll get area till here. If x is here, I'll get area till here. If x is here, I'll get area till here, and so on. Whatever x is, that area I'll get. I'll get area starting from x is equal to a and whatever that x is. So that is defined as R of x. Clear? Okay. So what is R of x plus dx? So let me just erase this and write it here. So this is x. So if I write another line here, which is in the neighborhood, this is x plus dx. So this is what? Dx. This is what? This yellow thing is what? Dx, correct? So tell me, what is R of x plus dx minus R of x? It is actually area till here minus area till here. Area till here minus area till here. Okay, so you'll get this area. Okay, so R of x plus dx minus R of x is this area, correct? Okay, but that area is also equal to, this is f of x and this is dx. That yellow area is also equal to f of x times dx, right? Because that is length and breadth of that triangle. So what can I conclude here? I can conclude this: R of x plus dx minus R of x is equal to f of x dx. So what is f of x equal to? R of x plus dx minus R of x by dx, correct? But what is this, the definition of? This is definition of derivative of function, right? So this is equal to derivative of R of x, which is R prime x or R dash x. So this is your first conclusion. Okay, so if you define some region as R of x, which is equal to area between a and x, okay, this is R of x. So R of x plus dx minus R of x gives you this area. R of x plus dx minus R of x gives you this area. Which area? Red area. I'll write down this red area, correct? Because R of x plus dx was still here and R of x was still here only. So if you subtract this area from this area, you will get this area. Okay, so that area is what? R of x plus dx minus R of x, but which is also equal to what? F of x times dx, because that is the rectangle whose breadth is dx and length is f of x. Clear? So you wrote that here, and you got this equation. But so derivative of R of x is f of x. That is your first conclusion. Second, f dash of x is also equal to f of x. Now f dash of x is f of x, as well as R dash of x is also equal to. That means what? Derivative of f of x. See, here we wrote f dash of x is also equal to f of x, right? f dash of x is also equal to f of x according to our claim. Okay. Now both derivatives of both the functions are same. Now a quick question for you. What is the derivative of x squared? It's 2x. What is the derivative of x squared plus 3? It's still 2x because derivative of x squared is 3. Derivative of x squared is 2x and 3 is constant whose derivative is 0. What is the derivative of x squared plus 100? It's still 2x. Correct, because 100, if your derivative of any constant is 0. What is the derivative of x square minus 100? It's still 2x. That means if derivatives of any two functions is same, they differ by a constant. If derivative of two functions is same, they differ by a constant. Correct. That means derivative of r of x is f of x, derivative of f of x is also small f of x, derivative of capital R of x is f of x, derivative of capital F of x is also small f of x. That means derivatives of r of x and f of x are same. Derivative of r of x and f of x. So derivative of r of x and f of x is same. That means r of x and f of x differ by a constant. R of x must be equal to f of x plus some constant k. Do you agree? Okay. Now what was r of x? What was r of x? R of x was area between x is equal to a and any x. If x is here, you will get area till here. If x is here, you will get area till here. That's how we define r of x. So what is r of a? What is r of a? So r of a is area between x is equal to a and x is equal to a itself. R of x is this. R of b is this full area between a and b. R of b is this full area. What is r of x? It is still any x you can take. What is r of a itself? It is area between a and a, which is a line without any breadth. So what is r of a? 0, right? If I put x is equal to a here, I'll get r of a equals to f of a plus k. But r of a is 0, right? Because area between a and a is a coincident line, so it is 0. That means I got the value of k. K is equal to minus f of a. So I can substitute this here. So what will you get? R of x equals to f of x minus f of a. I just found out value of k using a boundary condition or one extreme condition. Correct? Now, what do we need actually? We need area between a and b. I need this full area, right? For that, what should I use? R of b. Now my aim is to find r of b. That is what integral is, right? It is the area bounded by x is equal to a, x is equal to b. Okay, and curve and x-axis. So I need r of b. That is my ultimate aim. So what is r of b? So r of b is my ultimate aim. What is r of b? It is f of b minus f of a. That's what the definition is. So f of b minus f of a is what? Integral. See here. So what is the integral of f of x dx? First you write integral, you write upper limit and lower limit, and you subtract lower limit from the upper limit to get your answer. So that's what our derivation is. When you subtract lower limit from upper limit after writing the integral, okay, you get the area. And we also have seen that why you know f dash of x is small f of x, or why, see, I'll tell you. If f of x has integral capital F of x, then derivative of capital F of x is capital F of x is small f of x. I'll tell you what. So I'll tell you what. I'll write derivatives on the left hand side and integrals on the right hand side. You'll understand. So derivatives. So what is the derivative of x, or what is the derivative of constant? 0. What is derivative of x? 1. What is the derivative of x square? It's 2x. What is the derivative of x cube? It is 3x square. What is the derivative of sin x? It's cos x. What is the derivative of e power x? It is e power x. What is the derivative of natural log of x? What is the derivative of natural log of x? It's 1 by x. Now I'm writing integrals here. So integrals are opposite, right? So integral of 0 is a constant. Integral of you know 1 is x. Actually, plus constant also you get, but I'm not writing that. Okay, I'll write x plus some constant. Why that constant comes is because here, even if you have constant, you'll get, sorry, here. Here, even if you have, okay, okay. Here, even if you have constants, the derivatives are same because constant anyway it's 0. That's why we write a constant here. I'll get to that later. So what is the derivative of erase this. So what is the derivative of, okay, what is the derivative of 2, sorry, what is the integral of 2x? It's x square plus c. What is the integral of 3x square? It's what? X cube plus c. What is the integral of cos x? It's sin x. What is the integral of e power x? It's e power x plus c plus c. And what is the integral of 1 by x? It is natural log of x plus c. That means what, the formulas are different. If something is in derivative of something, then integral goes in the backward direction. Okay, that's what integrals are. And I'll write the integrals of important functions here. So let me write integrals. You have to remember them. So integral of x power n is x power n plus 1 by n plus 1. Integral of sin x is minus cos x. Okay, not cos x. That was derivative. Integral of cos x is sin x. Integral of 1 by x is natural log of x, not 1 by minus 1 by x square. That is differentiation. Integral of e power x is e power x. Okay, you have to remember these integrals. And some more integrals I'll write. Uh, so actually these are very important that you have to remember. Apart from these, other integrals occur rarely. Okay, so I will continue with integrals in the next class. Okay, so you just go through this lecture properly and keep everything in mind, because graphically what are integrals are also important, and why integrals are, how integrals are related to derivatives is also important. The proof is little bit complicated, not complicated, it's a little bit long, but if you know that, it will be well and good for you. If you don't know, not a very big problem, but you have to remember these integrals, and you have to remember what integrals are. You have to understand what integrals are. And we'll use integration throughout physics to find every equation, even why time period in simple harmonic motion is related to omega. Okay, why simple harmonic motion can be represented by x is equal to a sine omega t. Okay, all those things are based on integrals only. Okay, and you get integration in alternating current again. Okay, so because you have to take integrals when you are using inductors and capacitors. When you write the equations of inductors and capacitors, you have to solve the equations by using integration only. And I will derive these formulas: v is equal to u plus at, s equals to ut plus half at square, and v square minus u square is equal to 2s, again using integrals. Okay, one thing I'll do, I'll just derive those equations using integrals right now and end the lectures. Okay, now what is the definition of acceleration? Okay, let me use integration and dissolve. Derive those three formulas quickly. What is acceleration? Acceleration is what? Rate of change of velocity. Now in uniform motion, a is constant. In uniform motion, a is constant. So I'll put a here. I'll multiply dt here, and I'll keep v on the left hand side. Now if I apply integral on left hand side and right hand side, on the left hand side initial time is 0 and final time is t. On variable is v, so initial time is what? Sorry, initial velocity is what? U, final velocity is v. Correct? Okay. Now here there is nothing but if you watch care, if you observe a little bit, you can see that there is 1 there, which you cannot see. Okay. Now a is constant that comes outside. Here again 1 remains, and here you have dt, and here you'll get 0 to t, and again here you have u to v and 1 and dv you get here. Correct. Now what is integration of 1? What is integration of 1? X. That plus c you write when there are no limits. That is called indefinite. When you have limits, you need not write that c. Even if you write, it cancels. From upper limit, you subtract lower limit, right? That c anyway cancels. So integration of 1 is x. Correct? So if variable is dx, then you'll have x. If variable is dt, you'll have t. If variable is dv, you'll have v. Now here, what is the variable here? T, right? So integration of 1 is t. You put the limit, there is a here, lower limit, upper limit equals to, what is integration of 1 here? Here variable is v, that's why you write v, and here lower limit is u and upper limit is v. So here you will get at minus 0, upper limit minus lower limit, and here upper limit minus lower limit, when you substitute in place of v, upper limit is v again, minus u, you will get this. So what did you get here? V minus u is equal to at, which implies, if you rearrange, v is equal to u plus at. That means this equation I derived directly using integration. What did I do here? I separated variables. I sent t that side and I kept v this side and I integrated. If there is any t or v in the equation, here you don't have. You have to multiply t with t and you have to multiply v with v. Or you should take all the terms that are t on the left hand side along with dt, and all the terms that are like v square, v cube, whatever it is, you should keep them along with v. This is called variable separable method. Okay, so this is the first formula that I derived. Next formula. Okay, next formula is for displacement. What is v? V is ds by dt. Now we derive this formula u plus at. Correct. So if I rearrange this, ds is equal to u plus at times dt, right? So if I multiply this separately, it is u dt plus at dt. Correct. Now I am applying integration. Here, here, and here. Okay. Initial displacement is 0, final displacement is s. Initial time is 0, final time is t. Initial time is 0, final time is t. So what is integration of 1? S. Lower limit, upper limit. And it comes outside. Again, integration of 1 is, here you have dt, that's why the variable you get is t from 0 to t, plus a comes outside, and here you have integration of t dt, 0 to t. Now what is integration of x power n? It is x power n plus 1 by n plus 1. So here in place of x you have t, and you have t power 1. So what you will have? T power 1 plus 1 t square by 1 plus 1 2. So a into t square by 2. Again, if you put limit 0 to t, this I am writing again ut, and this I am writing again s from 0 to s. So what is upper limit? S. Here, what is upper limit minus lower limit? T minus 0. Here a by 2 I will take as common, and what is upper limit minus lower limit? T square minus 0. So you will get s equals to ut plus half at square. I derived the second equation also. It's quite easy. Now the last equation I'll derive and I'll end the lecture. So the last equation is what? V square minus u square is equal to 2as. But I have this equation. Which equation? V equals to u plus at. I'll use this and find that equation also. Which equation? V square minus u square is equal to 2as. Let me do it. So I'll write V is equal to u plus at again. The problem is I cannot integrate directly. Let me tell you what I'm trying to say. So dv by, okay. I don't want to use this equation actually. I don't want to use this equation. I'll use the definition of acceleration. What is acceleration? Acceleration is dv by dt, rate of change of velocity. Now in v square minus u square is equal to 2as, you don't find t anywhere. So somehow I want to eliminate t. So what will I do to eliminate t? Just see. So a equals to, a is constant acceleration, uniform motion. So dv by ds into ds by dt. Now you can see that these just multiplying and dividing by ds. Okay. Now what is by dt? Tell me. ds by dt is nothing but it's equal to v. So it's actually what? If I rewrite, it is v into dv by ds, correct? Now if I separate the variables, ds I'll send that side, so it becomes a into ds equals to v. I'll keep along with v because when I'm integrating, this variable should be with this. I cannot send v this side, correct? So I'll keep v on the side of dv itself. Now I will integrate from 0 to s. 0 final displacement is s, and initial is u and final velocity is v. Clear? Now a is constant that comes outside, 1 remains, ds 0 to s. And v, is it constant? No, v is not constant, v is variable because we are integrating with that variable. So what is integration of x power n plus 1 by n plus 1? So what is integration of v here? In place of x we have v because variable is v here. So v power 1 plus 1 by 1 plus 1. So v power 1 plus 1 by 1 plus 1, and limits are u and v. So what do you get here? A into what is integration of 1? S. So as you will have here, and upper limit minus lower limit 0 to s. Upper limit and lower limit is 0 and s. And here you will get v square by 2, and lower limit is u and upper limit is v. So what do you get? A into s minus 0, upper limit minus lower limit. Here 1 by 2 you take common outside, and you will get upper limit minus lower limit is v square minus u square. So what do you get if you rearrange this? V square minus u square equals to 2as. So we derived this also. Okay, I'm ending the lecture here. I'm ending the lecture. So we'll start tomorrow. Again, I think some of the lecture was not visible. It was not mirroring. So let me see. I'll just do it again tomorrow in the lecture. I'll just redo it. Okay. I'm ending the lecture. Okay. I think this derivation was not visible. Okay. Let me just check the video, and I'll do it again in the next lecture. Okay. I'll just redo this in the next lecture. So don't worry. Okay. I'm ending the stream now. Evening we'll have a chemistry lecture at 9 p.m. hopefully. So let's end the lecture here.